Okay, so this microphone's not working, but hopefully you'll get something from the laptop at the back. Right, I'm going to try and fly through this as quickly as possible. So congruent figures. If you see the word congruent, it means that a shape is exactly the same as something else. So if two things are congruent, they are exactly the same. Now they may have been spun around a little bit, but they would be exactly the same as each other. Its size, its shape, labeled in the same place. Okay. Similar shapes. Okay. These are enlargements of one another. Do you remember when we looked at enlargements, we would talk about how do we describe how much bigger something is than something else? Do you remember the phrase that we used? So say this one is this size here. Yes, that's what I'm say without saying more unmovable. So yeah, so there's a scale factor. So this may be half the size of this one, this may be double the size of that one. Okay? Okay. Initially, you'll need to write generally we look at triangles when we're looking at similar shapes. So you may need to decide if something is similar or congruent. And we've got this page again. So for similar triangles, corresponding side lengths when divided by each other will give the same ratio. So if we've got these two triangles here, so this shows me that these two angles are the same because they're both blue. This shows me that these are both the same because they're both purple. And these are both red. Okay, so that means that those angles are equal. So if they have three equal angles, they must be similar triangles. Okay, what that would mean is that this length here, AC, divided by this length here, PR, would be the same value as this length AB, divided by which length? PQ, nice. Which would be equal to this length BC over QR or RQ, so you need to convert it, yes? So they would be the same value. Now that could be a decimal value, it could be a whole number, but the ratio between each of them would be the same. Now notice I started with the same triangle lengths on the top and then the same triangle lengths on the bottom. You could not say that AC over PR would equal PQ over AB. Do you all see that would not make sense? Do you see the difference? Is anyone here? No? Yeah. Okay. So they have to be the same order, if you like. So the top triangle on the one triangle on the top, one triangle on the bottom. Okay. Right. The angles would also be the same as each other. So in some cases, it's not always obvious or very clear that they would be similar triangles. However, here you might say, well, look, that's a triangle and a trapezium. Would you? Maybe? Yeah. Wow. There's a lot of interaction then, I'd say. However, we could say that there's this triangle here, and then this triangle here. Yes? With these two lines here, what would we know about those two lines? They would be parallel, yes? So if we have parallel lines here, how could we describe, what would be the, what would be the relationship between those two angles? Say why, they are, what kind of angles?
Alternate.
No.
Corresponding.
Yes, just list them all off, take one of them right. In the exam you have to know which one's which, okay? So these would be corresponding angles. Remember that? Old days when we were doing angle reason? So they would be corresponding angles, so that means they would be equal to each other. And similarly, these angles here would be the same as each other. Obviously, this one at the top has to be the same for both triangles because it's exactly the same angle, okay? My suggestion to you would probably be to actually redraw a tiny sketch next to each other. So you can see that you have your red triangle here and your green triangle here. Because, for example, they may have labeled this one 2 and this 5. And so you need to know that this would be 2 and this would be 7. Okay? So just drawing a small sketch, you don't have to draw one of them bigger than the other. Okay? It just helps to establish which lengths you've got and which ones you're trying to find. Okay? Again, this shape here, you may think, well, that they're not similar triangles, but they are, because these angles here, how do we describe those? Vertically opposite, yes, vertically opposite. I love it, love it, love it. So they must be the same as each other, yes? They've told us that these two lines are parallel to each other. So, go back to your first thought, Emma, what was it? These angles here would be alternate, yes? So the blue ones will be alternate, and that means they are the same. And then these ones are obviously also alternate. So you have two triangles with the same three angles, therefore they would be similar triangles. Okay? Now, I would especially suggest that you redrew these ones, because people really get confused when it comes to establishing the corresponding sides when one's upside down. Okay? So I would just redraw them next to each other, and then that will enable you to label your diagram. I've got no letters here, so when we come to examples, it will become clearer. Okay, so this is going to redraw the shapes next to each other. Yes. And it's space to do that. No, don't worry about it. Okay. Right. We're asked, are these triangles similar? How would I show if they're similar or not? Suggestions? Yeah, find the ratio. So what should I do? 6 over 11. Is 6 over 11 equal to what? 4 over 9. Okay? How are we going to establish that? You could cross multiply. So you could say that 9 times 6 is
36. 54. 54. 54.
And what's 11 times 4? Okay, is 54 equal to 44? So they are not equal, so not the same ratio, so not similar. Okay? Okay, I've got away with writing the equal sign here because I said is 6 over 11 equal to 4 over 9. Okay, I've then made the statement that they are not equal to each other. Okay? So, good mental math, people. This is where we get to calculate it in quotes. Alright. Yeah, absolutely. Good job. Alright, so the following shapes are similar. So in this question they've told us that they are similar. We don't have to decide if they're similar or not. We need to find length x and y and angle w. So I would suggest angle w is the easiest one to establish. They should normally give you a little bit more information to make it clear that these two would be the corresponding angles, but let's just assume. So what would angle w be? 50, yes? So angle W would be 50. So if we're trying to find a missing length, so let's start with our unknown. So x divided by what? 7 would be equal to what? Which?
Bottom.
Yeah, 6 divided by 8, thanks. And why did we choose these two lengths here?
Because
They're corresponding lengths, and we've got numbers for both of them. Yes, obviously you can't choose this 4 because we don't know what y is, and we can't solve anything with 2 unknowns. So you've got x over 7 equals 6 over 8. So rearranging that would be 6 over 8 multiplied by 7. Okay, something divided by 7 is 6/8. You just multiply by 7. What value do we get? $5.25. Mary. Similarly, we're going to do y. So y over what? 4 is equal to, be careful, yes, Alexis, 8 over 6. Now, I just want to make sure that you're all comfortable with this. So this one, I had it was equal to 6 over 8. Okay, so I started with my 6 because the x was on the same triangle as the 6. For this one, I'm starting with my 8 because the 8 is on the same triangle as the y. Yes? So y is equal to 8 over 6 multiplied by 4, which is 5.3. We're carrying?
There's no recurring sign, but it's
I do dots personally. A line would be.
I don't
No, they don't need it. It's just it's naturally in some places lines. Is it not a three we carry?
It's not. It is. There's no recurring sign.
There is. Okay, so let's debate this in a minute. Alright. This is really pale board, I'm sorry. Yeah, because X is this and Y is this. Yes?
Oh wait, so that's
Alright, find X, given that the figures are similar. So we're told they're similar, so we're going to do a similar thing for each of these. So I'm going to start with my unknown. So X over, Amelia, what am I going to do? X over what?
X over 4.
Lesbian equals, keep going, Amelia.
6 over 3.
Lesbian, so X over 4, oh no, not X over 4, okay, try again. X is equal to 6 over 3 multiplied by 4, which is, yes, nice. Did we do that in our heads or did we do it on the calc? Awkward, right, 6 over 3 is just 2 times 4 is 8. Put it right side of that. So that's 8 centimetres. But please do use the calculators in the exam if there's likelihood that you could make a boo-boo. Right, doesn't have to be a triangle. We've got a random quadrilateral here. So who can I think of? Jada.
X over 8 is 3 over 4.
Anything else? So X is square root of 5 multiplied by 8.
Is 4.8.
And you are the calculator queen today, Emma. Trigger fingers.
What kind of shape is that?
Okay, so this has been cut. This is a corner of something been cut off. But it's similar, it's the same kind of situation. Ashley, what would I do here?
7 and 4.
I would suggest, you don't have to, but I would start with your unknown.
Okay, X over 5 equals 7 over 4.
Lovely.
Equals 7 over 4 times 5.
Crispy hands. Speedy Gonzalez, which is?
3.74.
Oh, she snoozed. She snoozed.
I will let you show
What kind of shape? More focused on the shape than they would shape. Right, okay, diagram shows a 2 metre wide path around a 12 by 8 swimming pool. Are the two rectangles similar? Justify your answer. These, to be honest, are becoming more and more common in your exam because they want you to think about things and they want you to explain things. They don't want you to just calculate something. So, we've got our rectangle here, we've got our swimming pool, it's a 12 by 8. Okay? We need to find the dimensions of the bigger rectangle. So what would the length here of the bigger,
16.
why would it be 16?
Because it's 2.
Good, there's 2 on either side, yes? You happy with that? So that would be 16. Because this is a 2 metre path,
Okay.
yes? But it's a 2 metre path on both sides of the swimming pool. See, this is 2 metres. So the 2 metres there and there. So therefore this length here would be 14. 16.
Because 12 plus 4.
Because this is 12. It's 2 plus 2. No, you're just saying okay, just shut it out. Absolutely. So tell me what this measurement here is.
16.
This one? Oh, I don't know. Okay, so same kind of principle. This is still 2 meters. So this is 8. So if this is 8 and this is 2, that makes how much?
Okay. 8 plus 2.
Which is, and then we've got this part as well. So that makes this 12.
Wait, because 8 plus 2?
Okay. Okay.
Are you sure?
This is not even size. How is it not even?
What's not even?
The pie.
Oh, right, the diagram doesn't look it. No. And they will always do this. You have to remember in, now I know this one doesn't state it, but in an exam they would definitely. They would probably write something like, this is not drawn to scale, something of that nature, okay? So you can't assume that just because it doesn't look like it would be 12 or 16, that it wouldn't be. You have to use the mathematical information that you've been given, okay? So we now need to decide, are they similar? So, what would we do? Is 16 over 12 equals to 12 over 8?
Maybe the other way.
Totally the other way around too, yes. So is it what's 16 times 8? What's 12 12? Is 128 equal to 144? So you would say not the same ratio. Oh, it's not the ratio. So not similar.
What is that?
Yeah.
So there's 2 12 language. One is it 12?
Oh, so we've done this 16 over this 12 first. And then this 12 over 8. Yep.
So that's the ratio.
So that would be called classed as a ratio, yeah. Okay? Now, which features make these figures have similar triangles? So, you can't really see on the board, but you can see it on your kids' paper, yes?
Yeah.
So a similar thing that I was talking about when I was looking at these triangles here. So, tell me the angle reasoning. Why? So these two are obviously both 90. Why are these two angles the same as each other?
The parallel?
Not parallel, it's corresponding. Okay, so we would say something like BDC, because that's how we would describe this angle, yes? Maybe with a hat on in the middle, is equal to AED, again maybe with a hat, because they are corresponding. So all angles are the same in BDC in triangle measurement. In triangle BDC and ABC.
That's a lot.
You would need to state that, yes.
How are all angles the same?
Well, when I say the angles are equivalent, so we've got 3 equivalent angles. I haven't written it very nicely in
What's the C
English.
equivalent?
Pardon what?
The C?
So here, I'm talking about at triangle BDC,
Mm-hmm.
and, oh, shush now, and AEC. So obviously angle C is going to be the same no matter what. Yes, is the thing? AEC, yes. AEC, sorry. Oh, this is angle AED. Oh, we could say angle AEC. Yes, same meet different gradient. C or D. So it ends up, shoots out to the same line.
So you have to say C for this.
You would have to say C for this one, yes. Because AED is not a triangle. Well, it's not a triangle, we're looking at. You happy with that? And again, that kind of thing is probably going to be more likely than anything else. because they're getting you to justify and give reasonings for these things, and they're becoming more and more common. We're going to find that these are a lot similar. So why are these two angles the same? They're corresponding, so you would say something like TPQ or R is equal to SQR, because they're corresponding. And similarly, PTS is equal to QSR, because they're corresponding. So 3 equal angles in triangles PTR and QSR. Yes?
For the first time, you said TPQ, you going to say TPR.
TPR, yes, totally. I looked at the first instead. Coats, my goats. PTR. Again, same thing. Where, yeah, for this PTS, yeah, I just looked at the first letter.
Why do you still have to make a triangle?
Well, for describing the angle, S would be enough because this is the same bit, but my final statement, I did say PTR. Yeah? These are all very good questions and comments because it shows that you're paying attention. Which is always a good thing when we're learning something. Oh, I make myself laugh. Alright, so what about this? Now, notice this looks like the bow tie situation and the circle theorem question, but there is no circle. Okay, so we can't use angles on the same arc reasoning here. But they have told us that these two angles are equal to each other. Okay, they've labeled them both as 40. So we know for sure that this angle here and this angle here are equal. Why is that? They're vertically opposite. So we'd say DCE is equal to ACB because they are vertically opposite. And because we have two angles already the same, it must mean that these angles are equal to each other because they both would be angles in a triangle at up to 180. Okay? So DEC is equal to ABC, angle sum of triangles. Okay, so again, 3 equal angles, triangles, DEC and ABC. Yeah.
Three equal angles.
Well, because we've got these are both 40. When I say, oh, that's not good English, is it? I shouldn't say 3 equal angles. 3 angles of the same amount. Is that better? In each triangle. 3 angles. So we've got a 40, a red and a green here. A 40, a red and a green here. So because you have the same angle measurements. So maybe equal is not the correct word.
What do you think able sum of triangles?
Because if I know this one is 40 and I know this one is the same as this one, then I know these angles have to add up to 180, and I know these have to add up to 180. So these have to be the same amount, no matter what they are. Does that make sense now?
It's like an end triangle.
Yeah, what is
Yeah,
that?
that's an in. My forward went a bit weird. What should we say here? Let's not say equal.
3 pairs.
3
Equal pairs. 3 equal pairs.
equal pairs. I like that. Or sets. How about sets?
Yeah.
3 equal sets. Oh shit
I
now.
like pairs more.
Fine, whatever you like. That word is up to you.
Okay.
I say Martha, you say Martha.
For the bow type thing, if it wasn't circle, two equally good,
Two on the top, the same, two on the bottom would be the same.
or would it be two opposites?
No, it would be top the same, lines on the same arc, meet at the same point on the circle. Yeah. Oh, and last one. Again, they haven't told us that these two lines are parallel to each other, but these angles here are equivalent, so they've labelled them as such. We know that these angles here would be vertically opposite, and therefore these ones must be the same in a similar reason because of the angle sum of the triangle. I guess I should write it before I write it. That's not good. Follow, is it? So let's say angle YVU is equal to XVW. They're vertically opposite. And YUV is equal to VW. You can use any letters. Well, not any letters, but the other order. And then you make your statement. I'm just going to write a statement because we're fighting everything about it. Right?
Could they not be corresponding?
No, because they haven't shown that their lines. No, and they wouldn't be corresponding anyway. They possibly would be alternate if they had shown us. If they'd shown us that those lines were parallel, you could use that reasoning. But because they haven't, we can't say that. I mean, they might say and prove that these two lines are parallel. So because they are the same as each other, they would be parallel lines. All right, so here we go. Let's do some more examples. So calculate the missing legs for the similar triangles. So these are the situations where we've got a big triangle at the top and then the big triangle at the bottom. Try not to see it as a triangle as a trapezium. So I'm going to draw my small triangle here. So I've got a 5 and a 6 measurement. And then my big triangle, what's my measurement here? 8. And this is my unknown x. So it took me 2 seconds to do that. But having that new visual is a lot easier than trying to struggle looking at this diagram here that can be confusing. Okay? So I've taken my information and I've put it on my own diagram. Then you're going to make your statement. So Samantha, what statement will I make here?
Right here?
Yep. Lovely jubbly. So x is equal to 8 over 5 multiplied by 6. Minus 6. How much? Oh, see, we should have units on these bad boys. So that would be a centimetre. And again, I'm going to draw my 2 triangles. So Jersey, what statement will I make here? So x is 8 over 5 multiplied by 7 is 11. Again. Up too fast and real good. Okay, so a piece of timber. Does it matter if you know what timber is or not?
Yes. It's wood.
Okay, it's a piece of wood, but it doesn't really matter whether you know what it is or not. They've actually labelled timber here, so they have a diagram. So let's not, but I say that because I know some people get hit up and panic that they don't know what the word timber is, and they say, I can't possibly do this question. It's like, no, you can do the question. It doesn't matter if you know what timber is or not. So we can see that we've got a wall there, we've got the timber, we've got a 1.6 fence, and we've got the measurements that they are away from it. We need to find out how far up the wall the timber reaches. So essentially we need to find this measurement here. Okay, so we're going to draw our two triangles. So this would be 1.6, this would be 3. This would be x, this would be 5. Okay? And Josie, what statement would I make here? That's good.
X over 1.6 equals
This again, so x is equal to 5 over 3 multiplied by 1.
2.2.
Wow, 2.6. Correct?
Yeah, no, it's like a 7, 8 footer down.
Okay, so let's put 2.67 to 3. Oh no, meters. I'm just going to say now, whilst I'm thinking of it, I have to say following rounding instructions was a bit rubbish in our mock we just did for a lot of you. So some of you just merrily went on with your calculations and rounded it to where you have to, okay? If it says, so once you've done this, I would suggest probably always, if I was doing this as my exam, I would write x equals 2.66666, okay, maybe 7. So I have several decimal places in. I then go back and check to see what the question says and see if it's asked me to round it in a specific way, and then I would round the answer afterwards. The mark schemes tend to say if you see the answer of 4 significant figures or more, give them the mark no matter whether they've rounded it correctly or not, okay? But if you only wrote 2.7, you're going to lose 2 marks, possibly, at least 1, because you haven't written it to the correct rounding, and you haven't given the full answer, okay? So always write a longer answer and then round it. It takes you 1 second more, but it could save you from losing a mark, okay? Right, let's practice some of the, oh no, I want to go. Right, okay, so it's like Groundhog Day. Well, we've seen this several times before.
We have one that.
No.
It can be though.
These are exactly the same things you've seen before. I cut them out of the other PowerPoint I gave you, the other smart document I gave you literally 2 weeks ago, I think. So, how do we go from one to another? So you're going from a smaller unit to a bigger unit. Are there more of them or less of them? So we would divide by, what's the pattern? 10, 100, 1,000. Okay? And then when we're going the other way, we would be multiplying by 10, multiplied by 100, multiplied by 1,000. Remember for weight or mass, the kilogram and ton, there's one extra addition. It's not 10,000, it's 1,000 again. So you would divide by 1,000 and multiply by 1,000. Okay, so that's just for mass. You may see the word ton, spelled T-O-N, if you're looking at American text. Okay. Square units. Their work must be the same because that's what people were doing in their mock. No. Divide by 10 squared. Divide by 100 squared. Divide by 1,000 squared. Multiply by 10 squared. Multiply by 100 squared. Multiply by 1,000 squared. Oh, what on earth would we do with their cube units? So we ask ourselves. We should square root them. Well, it wouldn't surprise me that some of you might consider that. But no, we would divide by 10 cubed. Divide by 100 cubed. And divide by 1,000 cubed. Right. Do we think maybe we might not send Miss Harrison into a set of nerves by actually remembering it this time?
Well, you'll never know. So it's fine.
I won't ever know, you're true. Absolutely true. So if you're just straightforward millimeters to meters, yes, you skip however, you see how many zeros there are, so you've got one. Okay. Yeah. Okay. Now, this is the one thing that sometimes people also forget, and it would have been mentioned probably in year 8, and I appreciate that we didn't recap this bit, but it wasn't in our exam anyway. But you are sometimes expected to recall the conversion between mass, volume, and capacity and volume. So 1 gram would be equivalent to 1 milliliter, which would take up the space of 1 centimeter cubed. So you are actually able to say that if you've got 0.8 kilograms of stuff, that would take up 800 milliliters. Okay, let me just get you to look at that for a few seconds. 0.8 kilograms, so I've changed that to grams, that's 800 grams. So therefore that would take up 800 milliliters. Yes, you all happy with that? So that is, a conversion that could come in handy when you're doing questions of this next nature. And it's all to do with similar shapes, okay? So similar areas. We know to find... Maybe I do need 2 lessons on this. Maybe I should be doing this myself.
Yeah.
Maybe I don't want to do too much. All right.